Welcome friends, in this one let's take a look at adding some rational expressions. We'll call this the missing factors method. So look at this, you have 1 over x plus 1 plus 2 over x. Now clearly we can tell that x is not the same as x plus 1. There's a different denominators, in other words, so we have to reconcile them. We have to make them the same somehow. So what we can do is observe the following. What is missing in x plus 1? Now you have to really understand that x plus 1 is to be treated as one expression. So what is missing in x plus 1 relative to x? It's x. In other words, what you can do is you can say 1 over x and then x plus 1. So in other words, here I've put an x in the bottom. Now I cannot just randomly, arbitrarily place an x and change my fraction. I have to compensate accordingly by putting an x in the top, this way. Let me stress this, the reason is simple, x divided by x is 1. Now look at the next fraction here. This is 2 over x. So it's 2 over x. What's missing here? Well, x plus 1 is missing. Again, you really have to see this x plus 1 as one unit. And specifically, that means that like this x here is not to be treated or seen the same way as this x here. So now you're going to have x times x plus 1. I've just multiplied by x plus 1 in this bottom, but I cannot just arbitrarily change the bottom. I must then also change the top accordingly. So here I'm going to put, for that reason, x plus 1 also this way. And in both of these cases, if you look very carefully, for the first one, x divided by x is 1. And the same thing with this, x plus 1 divided by x plus 1 is again equal to 1. So in both cases, you're just multiplying by an appropriate form of the number 1. What's appropriate about it? Because this is the form that will give x times x plus 1 in the bottom and x times x plus 1 in the bottom. And now you can work with this because the bottoms are the same. You can just say it's going to be x times 1, which is x. This is going to be x times x plus 1 for now, plus. Now, in this numerator, you have the 2 on the outside and x plus 1 within the parentheses. You can distribute that. You're going to have 2x times, well, plus 2 times 1 this way at first, over x times x plus 1. And then you can continue to work, so it's going to be x over, and now you're going to have this, x times x plus 1 plus 2x plus 2 over x, well, like this, x times x plus 1. And then just add up the expressions in the numerators. You're going to have x plus 2x plus 2, not skipping steps, over x, like this, times x plus 1. And lastly, x plus 2x will give you 3x plus 2. And then in the bottom, you have x over x plus 1 this way. And that's it. So this would be considered the answer here. Let's look at this next example. Again, you have now x over x minus 1 plus 3 over x. Our goal is to add these. So you make observations. With respect, for example, to the fraction on the right side, x minus 1 is missing x. Again, let me stress this. You are to see this here as one unit, this way, like x minus 1 within parentheses. So that means that this x in this position is not the same as the x in this position. Because this is minus 1, this is just x. Be very careful about that. So what you have to do is force these to have the same denominator. The only way to do that always in math is multiply by an appropriate form of the number 1. So you're going to do x over x minus 1. And I'm going to multiply by the x from here, this x right here. Okay? Look very carefully. Since I'm multiplying the bottom by x, I cannot just arbitrarily change the bottom. I got to change the top accordingly. So you got to multiply the tops also by x. And this is allowed again because this x in the bottom times this x in blue in the top, they're equal to 1 once you divide them. Then look at the next one. It's going to be 3 over x again. With respect to the fraction on the left side, this x here in the bottom, that denominator is missing x minus 1. So you're going to multiply here by x minus 1. But again, you cannot just arbitrarily change the denominator of a fraction without compensating. So on the top, you also do x minus 1. And this works again because x minus 1 divided by x minus 1 is 1, just like x divided by x is 1. So in both cases, you're multiplying by a form of the number 1. Not just any form, but the form that is bringing the two fractions to the same denominator, okay? So then you're going to work this out. So it's going to be x times x, which is x squared in the top. You can write this bottom as x times x minus 1 or x minus 1 times x. It makes no difference because here, remember, the operation is multiplication. So you can move the factors around. It doesn't matter the order. So for the next one, then it's going to be plus 3x, okay, minus 3 times 1, if I wanted to be very careful, again, over that x times x minus 1. And then you continue here. So you're going to have x squared over that same x times x minus 1 plus 3x minus 3 over x times x minus 1, not skipping steps. Now just, because the bottoms are already the same, what you can do is you can say equals, and you're going to have x squared plus 3x minus 3 divided by x times x minus 1. Copy the bottom only once, and then this would be considered the answer. X squared and 3x minus 3, those terms are all unlike. But remember what makes like terms, right? They have to have the same variable parts. Well, x squared is not the same as x, and definitely not the same as the constant 3. So that's the answer here. Now let's look at our next example. So again, I compared the denominator expressions. This is 2x plus 1 and this is x. They are different, right? 2x plus 1 is not the same as x. So you cannot just add these in there in this form. So you have to make them the same. So you're going to do this. You're going to say x squared over 2x plus 1. Again, this expression 2x plus 1 is to be seen as one unit, which tells us that whatever x is with the 2 is not essentially to be seen the same as this x here in a certain sense. What you'll need to do then is you need to multiply this by x. So now, what that means is in the top you also have to multiply x squared by x. It doesn't matter to the left of it or to the right of it, not important, okay? But the point is that this x in the top divided by this x in the bottom is 1, so you're not really changing anything, you're multiplying by 1. Now you look at the expression 4 over x, and then you compare. Well, what's missing in that denominator? 2x plus 1 is not present there. So you're going to multiply it by 2x plus 1. But again, you cannot just arbitrarily change the denominator of a fraction. So you could also then change the top, 2x plus 1. This is allowed because 2x plus 1 over 2x plus 1 is 1. And now, through this process, you see that we have x times 2x plus 1 as the same denominator. So we could already write this as x times 2x plus 1, and just work on the numerators. So x times x squared is x cubed. And what you have to do with this 4 is you can distribute it to the 2x and the 1. So at first it would look like this. Plus, let's say this way, okay? So plus 4 times 2x plus 4 times 1, if you wanted to be super careful with all the symbols. And then you can say x cubed plus 8x plus 4. And in the bottom you have x times 2x plus 1. This is x cubed plus 8x plus 4. All the terms are different, unlike, because this is x cubed, not the same as x to the first, and certainly not the same as a constant. So you would leave it in this form, and then this would be considered the answer. I'll see you in the next video. Please leave a like, please subscribe.